Hello everyone, welcome to our class ITS 305 Application Development and Emerging Technologies. I am sorry for posting late with this chapter. There are many things need to do in the Computer Information and Communication Technology office where I am currently assigned as a head office with no staff under with me, meaning all the things need to get done is done by me alone. Sorry again. I will double up my time to catch up with our lessons. Now, we are going to talk about the introduction to application development. Before we proceed, we will spare a moment to thank God and ask His blessing and guidance. We'll have a moment for our prayer. Father God, as we start this new day for new learning, as we ask for your guidance, lead us all the way. May you let us see you through your eyes, listen through your ears, and speak with your mouth. Be with us as we explore the world. Give us the heart to love and be kind to one another. Please watch over all of our instructors, students, and families. In Jesus' name, our Christ and our Savior. Amen. Again, good morning, good afternoon, good evening to those who are watching this video for your available time. This chapter will talk about four crucial topics in order for you to learn the introduction of application development. Okay, it starts with introduction to application development, and also um, talking about software development lifecycle, which is else or SDLC, and also application development approaches or methodologies that are used in software development or application development, and the types of application now in our era. And we'll talk about web development since we are going to do our application development through web development. So we are talking about in this chapter about what is front end and back end development, and also the database technologies available in the web development. Um, Third one is we have to know what is web servers, how it works, and how the architectures so that when we are developing our web application, we know how it works through web. And lastly, we have to know server stack. How can we set up locally our server host? Okay, that's all the things that we need in this chapter in order for us to work to set up our things for our application development. Okay, before we start, okay, we have to pause this video in your side, wherever you are, wherever you are watching this video, you take pause of this video and then write your answer on any paper available. Okay, I can take a picture for that, take a photo for that, because after this, you watch the video, you can go to our Google Classroom and you can find the activity for this on this part. I am doing this because I want you to really watch the entire video, no skipping, so that you are going to um, learn from zero second up till the last part of this video. So then after this, after having your activity, output activity, you can turn in with your assignment in our Google Classroom. So this will serve as your assignment and also your attendance for this chapter. Okay, so the question is for 32 points, what is application development? So before before I will discuss to you what is application development, can you share your idea about application development in your own? Okay, so the rubric is there also to guide you where how can you be graded for 32 points. So there are four criteria on this rubric for you to be graded. So again, this is serve as your attendance and assignment for this chapter. Okay, so we'll now go to our lesson. Okay, AD, not Anthony Davis in National Basketball Association or NBA. AD means application development. So what really is application development? Application development is the process of designing, building, and implementing software applications. So in our course this semester, we have to do four things. We are going to design an application, build an application, and also implement this application. Basically, we only have three things. Sorry to mention four, but we have to do three major things this semester. So this is really a very interesting courseware because we are going to develop an application. So we don't need only to directly develop it, but we are going to design. And after designing it, we are going to build it by through codes. And also, after building it, we're going to implement where that applications really want to work. So before that, before we have to be excited about how we can really design and build and implement our application, first we have to learn the types of softwares right now, so we can really identify what are the where we can start and how we can do in our application development. We have first is the system. Okay, so system, if you think software as being layers, the system software is the bottom layer. It sits between the hardware and the application software, so it's on the middle part. So later on, I will give you the software hierarchy so you can understand really what is intended for system software. Because we can really, because sometimes we are really very bothered. So what kind of application development we are going to do? Is this a system development or application development? But in our course, we are just really concerning about application development. Next thing, we have utility software. So utility software is a part of the system software and performs specific tasks to keep the computer running. Utility software is always running in the background. Okay, so when you say system, it's probably might have like application soft, oh no, operating systems. Operating systems like in the Windows OS, we have a mini versions. It's from Windows 98, Windows 2000, Windows XP, which probably you are not really familiar with because probably you are familiar with Windows 7, Windows Vista, Windows 8, Windows 8.1, Windows 10, and now we have a current one, which is Windows 11. So there are many operating systems available depending of what really a company or your phone or your laptop is really installed. So in the mobile phone, we have iOS, we have many versions of iOS also. We have also Android on your phone. There are many version of Android. So those systems or application software or no, those operating system really works in the hardware side. And utility software is also the same thing, but not entirely operating system. It might be like a a diagnostic tools that really keep running on your computer, like antivirus, um, the download manager. So those are utility softwares is really also close in time with the system software. And the last one, we have application software. This is everything else. So anything that is not an operating system or utility is an application or app. Okay. So what are those things? So everything that we are really using right now, Like in a PowerPoint presentation, there's also an application software. Like right now, you are using YouTube as to you are watching my video. That is also an application software. The browser that you're using right now are also an application software. So everything installed in your computer, your laptop, your mobile devices are really we call considered as an application software. So meaning in our course, in our DSEM, we are really want to develop an application like that. It could be a a mobile app, could be a web app or a desktop app. So it depends on us. But right now, I am just considering that we are going to use a web application for our entire application development. Okay. So next one is this one will discuss the computer system architecture layer. So this is why we are here. So really learn the overview or the architectures of the software. So here we have us here. We are the for a while. My pen is not working. Okay, pen. Okay. So here we are here on the top, which is are the user. Okay. So right now we have a software again, but it's application uh, program. It's application. So like for us, right now I am using a PowerPoint presentation. So I am using PowerPoint. Okay. This time being recorded, I'm using PowerPoint. That is the application where we present my discussion. So just during PowerPoint presentation, it might use I am using operating system, right? Because I cannot use operating system without application program without operating system. So in the background also I am using utilities, uh, somewhat like how I record my audio, I record my video. Everything here I record my screen is some of utilities that are really parted with the operating system. Okay, then we have a system software where the drivers were really work into my hardware, where I use my monitor, I use my headset, I use my mouse, my flash drive, and my keyboard at the moment where everything is also needed in my lecture today. It's really connected. So this is the hierarchy of the architectural layers for softwares for you to identify that this is what we intended to know, because here in the application program, that is where we are concentrating with our course. We are going to create um, programs intended for some uh, work. Okay, so I hope you've learned something with the architecture layers. Okay, so right now we go back to the definition again with application development. So again, it is the process of designing, building, implementing software applications. So again, it is the process, meaning we are going in this course, we have going to design, we're going to build and implement software applications. So software applications that really can be customized applications. It could be some big owners in some company that we might have using their manual way of using work. It may have creating a software to them to make their work much more easier and efficient. That can cut off labor costs and can now make automation. You can also have, okay, it can be done by massive organization with larger teams working on the projects or by single freelance developer. So in our case, we have doing to do it by work by team since we have a lot of I have a lot of students, so we can just group it you by five in order for you to work in a team settings with our course. So application development defines the process of how the application is made and generally flow standard methodology. So on the standard methodology, we have to really use the SDLC. that makes us our pattern of how we can develop our application. Okay, so again, AD, which is application development, is closely linked to SDLC, which is the software development cycle, which is we have sometimes it is commonly 6 stages, sometimes seven stages for SDLC. This is where how software is being developed. Okay, like for us, we have here a life cycle, a human life cycle, which is how life begins and how it ends. Here also how the software begins and how it ends. Okay, so we closely talk about SDLC. I know you have already discussed it with your other course. Here we can go tap and review what is really SDLC and how SDLC is closely linked to AD. Our concern is how we're going to develop an application, but we need to use the principles and concepts of SDLC. Okay, so let's start talking each phases and stages in SDLC. Okay, so SDLC we have to define first. So software development lifecycle is a structured process. So it's a structured process that enables the production of high quality, low-cost software in the shortest possible production time. Yes. Without SDLC, probably you might have siguro you can develop but not really a good one because you don't have a methodology or you don't have the principles that you are need for the development. So as a programmer, as a developer, you should observe the structured process for your production because might have you're networking it by one by one, we make it by team. So you are going to use you follow what is a structured process and it could help you for your production. So the goal for SDLC is to produce superior software that meets the exceeds of all customer expectations and demands. Because once you are going to develop application, there will be a customers and um, what are their expectations might be you will be going to work on it and also their demands. So make sure that all the requirements that they need including with your design will be included with your coding and also your deployment. So make sure that all the requirements for the customers will be met for your development. Okay. So this is the SDLC. We have several stages that we have go into. So we'll make it much a recap for this. I know you have learned from it from your other course. Okay. So it starts with the requirements analysis. So this is where we identify the current problems. So this well you can ask this question, what are the current problems? Okay? So this stage of this DLC means getting input from all the stakeholders, including customers, salespeople, industry experts, and programmers. Learn the strengths and weaknesses of the current system with improve as the goals. So in order for you to develop and create your application, you must first identify the current problems. So what is the reason why we are going to create this one? Like for example, um, in the school where it all manually logs their inputs, daily time records in the logbook. So it might have there is a problem. Probably it may run out with logbooks, it may run out with pen, probably inaccuracy of the time being entered. Sometimes the handwriting of some people like me is not good from everyone, so it might have an issue of accuracy. So you can identify problems. First stage in the SDLC is to identify the current problems because if there is a problem, there is a way we have to solve that problem, and that problems in terms of information technology. So it might have in that particular example, it might have to go to schools, you could go to the guard and tell us what are the current problems you encountered during this manual logbook of DTR. So you might have get some information there. For example, you can ask also the instructors or the teachers assigned with that campus and also the visitors what are their problems or the current problems using their in using the manual way of recording logbooks. So that is the very first step. You won't go directly to software development. Make sure you go to this first step, which is requirements analysis to identify the current problem. Yes, the next stage will be planning. Okay, so this will be answer this question: what do we want? So as a team that really go into application development, what is you really want? So by doing it, you can ask by the people around you, especially the ones that I mentioned, like for my example, those people that is a problem, what they really want, but also they want an computerized application system. So you, what kind of application software that really fit to their problem? So in this stage of the SDLC, the team determines the cost and resources required for implementing the analyzed requirements. It also details the risks involved and provides sub-plans for softening those risks. So in other words, the team should determine the feasibility of the project and how they can implement the project successfully with the low risk in mind. So we have a lot of planning here. So meaning your team will determine the cost. So how much it is to solve, how many computers you need to the organization, what are the requirements needed, blah blah blah. So you have to list some of those details and what are probably the problems. So everything will be recorded and be planned. So and don't always do not remember, do not forget what do we want. So meaning what we want in this project. So meaning you are going to for example in the logbook system you're going to listen a lessen the time of recording manually there because if you're manually recording and then there are many 20 staff or instructors are now on the fall in line. So it might have if timely. So to lesser the time of waiting, probably you might create a system to them, but it's really just swipe their ID and automatically records everything, right? So it records temperature, it records the time in, and also everything that is required for the time in. So that is included with the planning stage. Next is we have the architectural design, or we can see the design. So this question, it may help to by just asking this question, how will we get what we want? So how will we get? So meaning you're going to plan, design a blueprint from what I am telling you. For example, from um, one thing that you are going to make it all computerized and contactless record management logbook management system for that particular school, then you will plan what are those needed uh, blueprint. Uh, so what are the needed data? What are the specifications? What are uh, the use case? How many actors that we're going to use in your program or design? What are the plan for your database or the ERD? What is your objects and everything, data flow diagrams, every detailed designs for your plans will be talked in this stage where it starts turning the software specification, all the software specifications into a design plan called design specification. So we have a lot of design specification that I mentioned a while ago. So all stakeholders then review this plan and offer feedback and suggestions. It's crucial to have a plan for collecting and incorporating stakeholder input in this document. Failure at this stage will almost certainly result in cost overruns at best and total collapse of the project at worst. Meaning, you should talk about on the stakeholders what they really want also in this application. By just only giving idea from the requirements analysis, you should also talk with the stakeholders, the management, what they really want for their for their application. So it might have also give you good suggestions and feedback for your planning. That's why you don't have, so everything that's really want to your for your application will be designed in this page. Okay. Next will be software development. This is where we really write our design to coding. Okay. So this is build. Okay. So meaning let's create what we want. So at this stage, the actual development starts. It important that every developer sticks to the agreed blueprint, meaning the agreed design. Also, make sure you have proper guidelines in place about the code style and practices. For example, define a nomenclature for files or define a variable naming style such as a camel's case will help your team to produce organized and consistent code that is easier to understand but also test during the next phase. Because for the software development, I mean, in your coding, you may have a lot of programmers available to work with your uh, application. Make sure that all the teams are really focused in naming styling so that everyone is really doing the same, especially in commenting all those crucial logical part of your program where everyone is really aware of what is really that particular code must very help to the team because it may have some your programmers may have also not available, so some of the programmers will easily come in for the replacement of your develop programmers and would have you for saving a lot of time rather than just to really familiarizing first the coding style of the programmer, meaning all of the programmer must use same coding style, saving variable name conventions and everything commenting style also will do the same. It will help. That is the process now where your design, your analysis for your requirement, your plan, and your design is now really into coding. So this is now where it's very exciting space where you can see now your actual application. Next is the testing, which is code test. So did we get what we want? We answer this question. So in this stage, we test for defects and deficiencies. We fix those issues until the product meets the original specification. So we are now testing if our program is really what we design in our architectural design phase. As really this button is your work, everything is now working properly. So if there is a problem during testing, we may now go back to the software development where we have to solve this issue. But if your application is after testing, it will have no problem, no error, then you can now go to deployment, where it's actually where um, the stakeholders will take place also. So the step, so you can verify the code meets the defined requirements. So based on your architectural design, uh, is your program working really here? If it's not, then it will go back here in the software development and look for the design. to make the testing work. Okay, that is what we call the code testing. Okay, then now we go to deployment or the software deployment. Let's start using what we got. Okay, so by first we do the requirements analysis, taking first the idea of what is really the problem, then creating a plan for that problem, and now getting the design of that particular problem and what we're going to actually do for your application. Then after that, converting those design into codes and turning into application. Now after that you have to test, and the testing is correct and no more error based off the design. Then you can now go to the deployment. Okay, so deployment. So at this stage, the goal is to deploy the software to production environment so users can start using the product. However, many organizations choose to move the product to different deployment environments such as testing or staging environment. So we can test, no, but there are some that they will use this the final to not to public so that they will have another screening for testing for their end, because this testing is only the end for the developers. For deployment, we have the end of the stakeholders that really what they want really meets. Okay, so the application meets what demands, what we're talking about, the demands and their expectation. So make sure once it is being deployed, probably they're in their official server or not official site, probably it's considered online. So this allows the stakeholders to safely play with the product before releasing into the market. Besides, this allows the final mistakes be caught before releasing the product. Okay, so this you have the pre-deployment, but that is not really uh, if there is a problem for the this stage, it might the the stakeholder might will have also go to your architectural design and revise their expectation and what they really they want to expect under their demands, so that you can now change their design and now go back to the software development and go back to testing. Okay, then deployment again. But if there is no problem, then it's the software is now being deployed. Okay, so next stage, I guess that is the last stage, but we have an additional one, which is software maintenance, because sometimes we have to do maintenance in our software while deploying it. There will be some revisions. So let's get the closer what we want. Okay, so the plan almost never turns out perfect when it meets reality. Further, as condition as in real world change, we need to update and advance the software too much. Yes, as we can see also in our application phones in our applications, in any versions of apps you install in your computers, there are also upgrades where we met the software meets the requirements of the user. So probably in this year 2020, you deploy the system, but for 2 years from the deployment, you should have a maintenance, because probably the requirements set by the stakeholders from 2022, then it might change. Like for example, there are many softwares that are being updated during the pandemic. Before the pandemic, we might have no the systems are not really online, but due to the pandemic, see some systems are really centralized. That is why software maintenance is very important also, because it changes the nature of your application. So once there is software maintenance, that will leads also for a new requirements analysis, a new plan, a new design, and a new development, and also new testing and a new deployment. So that is why software development never ends because of software maintenance. So that is why we call it software development life cycle, because it is a cycle. Once the software is doesn't end, doesn't stop, there will be a maintenance for that. Once there is a new maintenance, there will be new requirements analysis, new planning, new design, new the soft coding, and new testing. So that is really what SDLC, the overview of SDLC about. So well now, so there is a quote: if you fail to plan, you if you fail to plan, so meaning if you are nasayop ka sa pagplano, you plan to fail. So meaning, uh, in order for you to plan your application, to work it, uh, to make it much more uh, a good, to develop a good application, you must really not not to fail to plan. You are going to plan it. A good plan can make your application not to fail. So the system development lifecycle gives a structure to the challenges of transitioning from the beginning to the end of your project without forgetting step. So in your application development, without SDLC, it might have no methodology. We don't have any things na ato ang mabasihan for our application development. This is why we are going to use SDLC for us to really guide it for the steps and stages during our application development. That is why SDLC is very close to uh, SDLC. So we will use SDLC to our application development journey. So now we know the software development life cycle. So we're really going to use some models or approaches um, in SDLC. So there are a few that I will mention with these slides. First, we have waterfall model, V-shaped model, iterative model, spiral model, Big Bang model, RAD, which is Rapid Application Development Model, and lastly we have Agile model. So these are the models for the SDLC. Since depending of the project, depending of the nature of the application, the teams, number of people working on the team, and also the time constraints, that will be have different approach in developing your application. We will have to mention some of the SDLC models. It might have really not all of the your application that we're going to develop might will be using these models. So it depends. We will just run into each models in SDLC depending of what kind of application you are going to develop and constraints in developing it. We might have going to select the best SDLC models in your application. First, we have waterfall model. So this is the diagram for the waterfall model. So it is the oldest and most forward of structured SDLC methodologies. Finish one phase, then move on the next. No going back. So it is a no going back approach for waterfall model. So we have here um, each stages are going back to 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 down. So finish one step. So first you have requirements. So basically that is a principle of the SDLC. So you go first with the requirements analysis. Finish it with this task. After that, we have here going to design the system design. So if you have problem for system design, you go back, okay, to requirements analysis. Okay, so you cannot go to the next without really finishing your previous one. So system design. Now system design. Then after you're going to have the implementation, which is the coding. Okay, then after coding, if there is a problem with the coding, so system design, you can go back to the system design. Probably there is a problem with the system design. So before going to testing, all of the requirements of the system design will take place. So after implementation, there's after everything is being coded, you may now test the program or application. So if there is a problem with the testing, you might go back to implementation or writing the codes. So you can go back one step at a time for this approach or methodologies. Then after testing, we can go to um, deployment. Then if there is a problem with the deployment, probably there is a problem because there is a meet of there is no the demand and of the stakeholders not met. So probably you can go back to system design and go back to implementation again and testing. And lastly, we have to deploy. We have make sure that we have to do maintenance with our program. Once there is a maintenance, there is a set of requirements analysis. Okay, so this is what we called for the waterfall model. So, but early delays can throw all of the entire project timeline. And since there's a little room for revisions, once a stage is completed, problems can't be fixed until you get to the maintenance stage. This model doesn't work well in flexibility is needed for the project long-term ongoing. So, some the last definition um last definition um you should start every once there is a requirement analysis, there is no turning back. But that's one of disadvantage for this one. You cannot going back. Once you go to the system design, there is no turning back. So but there are some developers who used this waterfall model by just turning it back on the previous one to make it much more flexible. So this is what for waterfall model is. Each stage relieves on information from previous stage and its own project plan. Waterfall is easy to understand and simple to manage. That is the advantage for waterfall model. Going to now in V-shape model. So as you can see, there is now forming V-shape for this particular model. So, also known as the verification and validation model, the V-shaped model grew up out of waterfall and it's characterized by a corresponding testing phase for each development stage. So, nakalahi niya. So, like waterfall, each stage begins only after the previous and has ended. So, like for example, in the V-shape, first in the requirements analysis, there will be a verification. So, we have here the verification, which is the acceptance testing. So if there is a requirements analysis for the stakeholders on this particular part, the the people that were going to use the system, once there is a requirements analysis, you go with acceptance testing, and this is that you are going to have a test design for acceptance. Okay, so once this stage is already done by testing the design for the acceptance, you can now move into the second one, which is system design. So, the system design, there will be a system test design. Then it will be testing of the system. But now, remember that there is no system yet because the code here is really the one that makes it much connecting with the lines. So there will be a system test design for system design for you to really test it during the system testing. Now, once you have now system test design for your system design, we can now go to the architectural design. So there will be integration testing on this part. So there is a verification. That is why we have here verification and validation model. So there is a verification for architecture design. So that if there is now a test for this design, we can now move to module design. So there will be a unit test design for every module. Now, once there is now coding, okay, once there is now you now code your design. So once you code the unit testing, there will be a unit test design. If you go to integration testing, there will be a verification or validation for integration testing. Once you have now systems testing, you have now also a verification system test design. And now we have also the acceptance testing that based on the acceptance test design. So everything is working, having a validation and verification for this model. So it might very good for you for use this one if really if you have a lot of time, because it might really good for all the stages that has a testing, unlike for the waterfall that it might you going to test it later na after na sa coding. Okay, so that is the V-shape model, and we have iterative model. So this is the diagram for the iterative model. So the iterative model is a repetition incarnate. Instead of starting with the fully known requirements, you implement a set of software requirements, then test, evaluate, and pinpoint further requirements. So one advantage over the other SDLC methods, these models gives you working version early in the burst process and make it less expensive to implement changes. Once disadvantaged resources can quickly be eaten by the repeating process again and again. So meaning you don't have first you are just having a first requirements. Okay. So based on the first requirements, you have a build one. You are going to have a design and develop these particular requirements, then test it, and then implement it. After that one, probably there will be a requirements based on the after implementation, there will be a new requirements. You can have the new version of version 1.1 for that particular application. Then you have design, and then testing and implementation. Then after implementation, probably there will be another version, there will be a requirements, another version for that. So that this is very good for some. We don't know really the requirements of the particular applications, but the really disadvantage for this one is very time consuming. We must really before we have a good application, we always have numerous repetition or iteration so that we can get the best of that application. So we have further, if you can, it is a good for those to have no further idea about the requirements of the application. But if you have a good and have a uh, all the specific requirements needed, you have list it down, detailed one, you might use the waterfall and the V-shape model. So for example, if this application really works, for example, if you were going to create an application um, like for example, siguro before wala pa yung online sabong, like probably some of the developers using the online sabong or developing online sabong might have as a limited requirements of what they are really working. They have really built and built and built. So that means a full version of it might have the correct one that you are using right now. So depending of the requirements of the application. So probably you might create, like for example, if you might create an applications where if you are going to wait for a series, you will know what will be the next bus will be passed through your location. So if you were going to develop that one and there is no limited requirements needed, you might have an iterative model to use that particular uh, problem in that application that you're going to develop. Okay, then a new version of the software is produced with each phase or iteration. Rinse and repeat until complete system is ready. So mas nice siya if ever you don't have the requirement. Well, I don't have the idea of the full requirements. So because you can set a lot of version of it. Okay, then we have a spiral model. You can see the diagrams. The diagram. We have four phase. We can have here. We call it um, the four quadrants. The first is identification, second is design, three construct and build, and we have evaluation and risk analysis. So we can have also no identification of the problem, design, coding, and then evaluation and risk analysis. So the same thing in our software development life cycle. So here, this model allows for building a highly customized product, and user feedback can be incorporated from early on in the project. But the risk you can run is creating never-ending spiral for a project that goes on and on. Like for example, the first thing that we have is the system requirements and unit requirements. You have to identify the system requirements and unit requirements. Then you have going to design here. This is the first step that you are going to take here. So this is the first one, identify the system requirements and unit requirements. And we have you have to design the module design and system design. Once you have to create now the system design, you have now build one. You build one, and we have here schedule monitoring and customer feedback. Once you have now that feedback, we have now a new business requirements, architectural design. Okay, you build. So there will be a spiral of things that you're going to work on your uh, development. Okay, but this is the one of the most flexible SDLC methodologies. The spiral model takes the cue from the iterative model and its repetition. The project passes through four phases over and over in a spiral unit completed, allowing for multiple rounds of refinement. So it's very easy because and it's very helpful for you because it's every spiral that you have, it always um, evolve in the four phases of SDLC. So this one is more flexible. So you can create a much more um things here compared to the uh, V shape and the waterfall model. Here we have another one, which is the Big Bang model. A bit an anomaly among SDLC's methodologies. The Big Bang model follows no specific process and very little time is spent on planning. The majority of resources are thrown towards development, and even the client may not have a solid grasp of the requirements. So, especially if this is a Big Bang model, probably if there will be a client here or the stakeholders, so a we'll just create a market uh, directory application. Like we don't know, we have here is a market, all of the inventory of unsa ilang naipaligya, it will be saved in your database, and you can all the client will just search their goods in their phones, so that if they will go to the market, they will know if asa the pita available, and they'll just no need for you them to going back and forth to whatever stall in the market. But the client doesn't know even the correct requirements. you just ask them to develop that application. You might have this one is the best methodology for you. But Big Bang is not recommended for large complex project. It is high rest model. If the requirements are misunderstood in the beginning, you could get the end and realize the project may have they started all over again. Yes, so that is very true. If it's not good planning for the beginning, we might have create an application which is really not good also. So that is the Big Bang uh, model. So this is one of the SLC methodologies typically used for small project with one or two software engineers. Okay, and we have agile model. This we have here the diagram for agile models. We have plan, design, we launch it, and then after that develop, test, deploy, review, plan, design, launch. So by breaking the product into cycles, the agile models quickly delivers a working product and is considered a very realistic development approach. The model produces ongoing releases, each with small incremental changes from the previous release at each iteration in the product is tested. So this model emphasizes interaction as the customers, developers, and testers work together throughout the project, but since this model depends heavily on the customer interaction, the project can head a wrong way if the customer is not clear in the direction of he is want to go. So there is no such thing as the agile model really consider really depending on the stakeholders or the clients um, plan. Okay, but it's a good one in developing if the concept of the project is not really clear. This is for agile model. There are sometimes this is the most commonly used methodology right now, since software's application right now it's really uh, emerged through the client side, the client uh, um, idea, and the developer also just relying on the client's idea about the applications. It might have good methodologies by using agile model. Okay, we have RAD, which is Rapid Application Development. Rapid Application Development is a software development methodology that uses minimal planning in favor of rapid prototyping. A prototype is a working model that is functionally the equivalent to a component of a product. So as you can see, define project requirements, then using user design, you have a prototype, you iterate the prototype and test, that is the user design, and we have the rapid construction feedback. Then if there what really the feedback is, you go back to the prototype, iterate it and test it. So once there is now the feedback of the construction is good, and now go to the final implementation of the project. So it is very really good into if you are really uh, in the if you're really have enough time in development. So this one you have plan I do have planning stage and directly go to the testing stage. But that is not applicable for us since we have to really define first the requirements before actually developing the application. So in the RAD model, the functional modules are developed in parallel prototypes and are integrated to make the complete product for faster product delivery. Since there is no detailed pre-planning, it makes it easier to incorporate the challenges with the development process. So RAD projects follows iterative and incremental model and have small teams comprising of developers, domain experts, customers, representatives, and each other IT resources working progressively and other components of our type. The most aspect of this model is to be useful, successful, and to make sure that the prototypes is developed are reusable. That is for RAD model. Okay, so right now we take it slow. Okay, so another assignment and attendance for this video. Post this video again. Write your answer on any paper available in your home. Then look to our classroom regarding with this activity after the video, after watching this video, and turn in your assignment. So this is assignment question number 2. Um, Based on your idea from our my previous discussion, which SDLC model is right for you? So if you are now developing an application, what would be uh, SDLC model that you are going to use in your development? So in your own idea, okay, write it on your paper and take a picture of it. Look for our Google Classroom regarding with this activity and upload it uh, on your to the desk activity. So that is question number 2. So this is to test you if you're really um, watching my lecture video. So that's it, no? So we'll now discuss different types of applications. So when you hear the word app, you might think we are referring to the traditional mobile app such as the Facebook app or iPhone. So types of apps. So it could be desktop, could be Windows, Mac OS, Ubuntu, Fedora, Chrome OS. So there are kinds of desktop applications installed there. You can have PowerPoint presentation, Word, Excel, also word processing, graphics like Photoshop, Illustrator, sound music for music apps. So that is application that you can use during desktops. That is the type of application. And they will have an application run through web. It could be run by Google Chrome, Mozilla Firefox, Mozilla. Okay, sorry for that. I duplicate it. Safari web browser and Internet Explorer. So those are browsers that really supports web applications. So web applications like Facebook.com through web. Some websites available in the web are this kind of web application. Some of applications also can be found in mobile, and those platforms will be Android OS, Bada Samsung Electronics, BlackBerry OS, iPhone OS, and iOS. So these are the types of applications under all platforms. So why I'm going to see you this because we will going as a developer, we are going to talk about what are the platforms for our applications to be run. Some right now, depending of the popularity of the app, some of the app like Facebook originally has its on the web platform. Then then since there is a web, then they later create it Facebook app in mobile, and now we can have also use Facebook app in their desktop. So we can install Facebook in our store in Windows application. So some of applications are really have the types of apps really caters in all platforms. So, considering this particular thing, we have a lot of things to develop because we have to develop your application in the desktop platform. You can also develop it in the web platform and also for the mobile. So, right now, I want us to really concentrate with the web since web can be run also through desktop by the use of the browsers, right? A laptop. And also in the web, you can also use mobile by the use of also using these browsers. So these browsers really give us the opportunity that our web application can be viewed also for desktop and mobile. So in our case, you might select web application in our application development because our program might can be used in the desktop and also used in the mobile. Because if we concentrate only on for the desktop, we can only develop desktop apps intended only for a certain platform. Also, if you're going to develop only for Windows application, might have also create an application only for Windows or only for Mac, only for Ubuntu and Fedora because each platforms here can be used different um, programming language or call it programming language. But here the same thing with the mobile. If you're going to create a mobile app for Android, for Bada, BlackBerry, and iOS, you have different code structure also, different code structure. But here, in web application, if we were going to concentrate with a web application, we are sure that those platforms in web and mobile, desktop and mobile can install these particular browsers, and every browsers there can access to our web. So it's very helpful for us to hitting two birds at the same time if we use web application. So that is why I am encouraging you now that we are going to learn web app. Okay, how to develop web app. So that's why we can consider why there are types of applications. So the type of application that we're going to develop in our course is officially a web application. Okay, so hopefully you understand that. So now another assignment and activity that you're going to work. So post this video, write your answer on a paper available in your home. Okay, again, look for a Google Classroom activity for this activity. Turn in your activity again. So this is assignment number 3 that serves also um, this serve as your attendance and assignment. Okay, question number 3. Explain what is the best type of app you want to develop. Share your own idea. So what is the best type of app you want to develop in your own idea? Okay, again, please read the rubrics for the criteria for you to give it 32 points. Okay, now we can now proceed. Okay, we are now on the web development. Okay, web development. Web development refers in general to the tasks associated with developing websites for hosting via internet or internet. The web development process includes web design, web content development, client side, server side, scripting, and network security configuration, among others. Web development is not a single activity. It is an umbrella term for several fields of website creation. The primary forms of web development are client-side, server-side, and full-stack development. Both client and server-side programmers are necessary to make website function. Skilled developers who work in these fields often need to work closely together to create a web design and functional product. So, types of web development. So, we have front-end development, responsible for the look and feel for a website, back-end, responsible for building and maintaining code that runs a website, and a full stack covers both front-end and back-end responsibilities. So in your case, you might have enjoy assigned with the front end, and some will be enjoyed on the back end. But some of us or you will be a full stack developer where you are good in front end and back end development. Okay, so client side development. So focuses on creating the part of the website that can user can interact with. So sometimes client-side development is also referred as to front-end development, as it focuses only the front part of applications that users can see. Like for example, in the image you can see the UI for YouTube. So the front end developer is only concerns the look and feel of this website, how the navigation works, how the links are works, how the contents are pre-arranged, and also the look and feel. What when you click something, what will be the shown from the user? That is really entirely covered for the front end development. Client-side developers complete a variety of tasks, including creating a website layouts, designing user interfaces, adding form validations, adding visual elements like colors and fonts. Those are the key areas of a client-side developers. Some common client-side languages have HTML. It's a markup language. Is the standard language of for web development. So you have to learn HTML. You have CSS. It's a design language that developers can use to add visual design elements to a visual website coded in HTML. We have JavaScript. Developers can use JavaScript to make website dynamic and interactive. We have VBScript. It's a general purpose to client-side scripting language supported by some browsers. Developers can use VBScript to add interactive elements on website. So sometimes the work for VBScript is also the same with the JavaScript. But if you're really using the Visual Studio, some of can be working with the VBScript. But in the common client-side languages, you might have to learn first the basic concept of HTML, and followed by the CSS, and lastly for the JavaScript. That three will work if you know learn if you learn uh, front end development. You must study at least three languages for you to work. This is for the structured, this is for the layout and layout and arranging, and this one is for the look and feel and the dynamic content interaction. So each one of the languages has different work you can go in your program in your front end development. HTML will have the structure, the navigation, the links will be used in CSS for the HTML. CSS will make the color, the look and feel. That is for the CSS, and for the GS, the interaction. When you click something, there will be a hover, a pop up that will work for the JavaScript. So different languages, different work to do, but all in all, they work together to make your client side will be look like uh, magnificent. Okay, these are where you can learn the basics for front end. Let me zoom in. First, you should learn the basic about HTML, CSS, and JavaScript. If you want to learn more bit deeper, if you're now going to learn about much more in CSS, you can use how can you learn responsive web. So meaning you can you work your website will be run to any screen devices. You know all the devices has different sizes, so you can all your look and feel of your website will be the same to more devices. You can have preprocessors like SAS, LESS, Stylus, and REST post CSS, where you can create you can make your styling much more we call it much more flexible by having a variables. And you have choose a framework, foundation, bootstrap, materialize, and CSS, where in our development also use framework for CSS, and that will be used or we will going to use bootstrap for that. Okay, then we can also getting deeper for JavaScript. We have a lot of things that we can do. We have ES6, task runners, we can package manager, testing, type. We have a lot of things. You can just choose a framework for CSS. We can have Angular, React, Vue, the GS. Everything here are really working for a much more interactive website. It can also work for once of this framework can be also used for back-end development. You can also have here CSS, SVG, and JavaScript to save much more loading time for all resources. And everything here is really go deeper. But at least for the front end, you must really learn the three basic one, HTML, CSS, and JavaScript. And if you want much more nicer and easier, use jQuery library for JavaScript for light use of interaction. Okay, so that's it. How we can really learn how can we uh, connect those languages for the front end development. So best client side frameworks. So we can have Angular. It's a front end JavaScript framework sponsored by Google and their latest version of Angular. Backbone.js, a JavaScript framework that uses model view presentation. MVP designs paradigm best suited for single web page application development. So there is no more reloading of page if you can use Backbone.js. And we have Bootstrap. It's an HTML, CSS, and JavaScript framework for building a responsive and mobile-first website. It was created by Twitter. So might have used this framework for our development for because it is an all-in-one package. It is an HTML, CSS, and also JavaScript that is really in one framework. That is really these languages we are really uh, needed in the front end development because we have a lot of concern also for the back end development. I know you are being on your web development, you have also discussions for how we can use these frameworks, but in my case, I'll be using Bootstrap for purely front end development. Now we gonna go to the server side development. Okay, so this is how interaction for the server. So it's a web server. Every request, it's an HTTP request, hypertext transfer protocol. It is a request from the client to the server. So the server will now accept the protocol and go to the CGI program, meaning whatever the request from the browser will be processed through the server, and it will be now go back again to that pattern, and it will end up to the web browser of the client. So that is what we call the server side and client side approach. So here, server side development focus on behind the scenes development, and server side development is also referred to us as a back end development. So this type of programming is important because web browsers or clients interact with the web servers to retrieve information. Common server-side tasks include coding dynamic websites, developing web applications, connecting websites to databases. So those are really work for for the server-side development. Some common server-side language. We have Java. It's an object-oriented programming language that developers can use for a variety of purposes, including software and application development. Python is an object-oriented general-purpose programming language that developers can use for web development, application development, operating systems, and other purposes. PHP is a scripting language developers use to create websites and web applications. We have Ruby is a highly popular programming language that is used for lots of things from web app development to data analysis. So these are some common servers. But I am now planning to use PHP as our official server-side language for our web application. So we were going to learn for from HTML, CSS, JavaScript, and we are going to also learn PHP in developing application. So these are the backend languages that how we are connect. So it's up to you what we're going to do. So it have the Ruby, have Node.js, another this is a JavaScript framework. We have Python, we have PHP, we have a lot of um, servers. So right now, I'll be focusing only on PHP So the latest version right now, uh, the year 2022, is PHP 8. So we have a lot of testing for PHP. We have PHP units, code section, exception, and mockery. And we have the frameworks. We have the the best framework in PHP is Laravel. Okay, Symfony, Slim. But we are going to use what is a nicer version also. It's very really really um, follow the pattern of MVC. So later on I will discuss that one. So that is we how PHP or the backend works for the because once you have selected the language, make sure to select framework for easy development also, because if you have using framework in your development, you don't need for um, security for structuring the folders or the directories. The framework will help you do that. So that is why once you select some of the languages, you lead to some frameworks. As you can see, Ruby, you have also frameworks and testing. Node.js also framework and testing, because once you deploy it, you need to test it. Okay, so make sure that the testing and the framework will also correspond to each other. Okay, so that is the backend technology or the languages uh, right now. So best server-side frameworks. So we can see I have here the list of it. First with the Java, we have Spring, Hibernate, Struts, Wicket, GWT, Drop Wizard Play, and Vaadin. Python, we have Django, CherryPy, TurboGears, Flask, Web2Py, 2Py, Battle, Falcon, CubicWeb. And the PHP, we have the first is the Laravel Symfony. The third one is CodingNighter, Send Framework, Fuel, PHP Slim, Falcon, and Aura. But this one that we are going to use, since we are using PHP, I use CodingNighter because they're very this one CodingNighter approach with the MBC, which is the model view control, that really helps that programmer hide all the controllers and the views and the database connections. So next topic, we will now discuss about what is CodeIgniter. So right now we will just continue with the frameworks available in the languages. We have the Ruby, we have Sinatra, Camping, Rames, Gulayat, Hanami, Pedrono, Nene, and Cuba. So there are a lot of frameworks. You know why there is a framework to help us developers. They now start from scratch. They have already have a frameworks to help their development. Frameworks is very helpful if you are developing large web application with lower manpower. Okay, then now we have another activity. So just take a pause with this video. Write your answer on a paper and available in your home. And again, after this video, look for the Google Classroom regarding with this activity and turn in your assignment. Okay, this is assignment number 4. Then this is the question. Choose a web development career you want to work with soon. It could be a front-end developer, back-end developer, or full-stack developer. Explain your thoughts. So in your idea, what would be your career soon? It could be what would be it could be a front end, a back end, or a full stack developer. Full stack means you are very familiar with the front end and the back end. So write your answer on a piece of paper and turn it in on your Google Classroom. Okay, now we have database technologies. So a database can be referred to as a room inside an office where all the essentials informations and reports are stored. The information which gets stored is extremely sensitive. Hence, we have to be ultra careful while we access the information in the database. Top 6 database languages. We have the Oracle, MySQL Oracle Corporation, also MS Server, MS SQL Server, PostgreSQL, we have MongoDB, we have MariaDB. So probably we are going to use the server MariaDB, okay? Because in our server stack, later on we discuss why we are using MariaDB instead of using MySQL. But still the same, we are using MySQL syntax, but the server is MariaDB. That's mostly related to each other. So that are the 66 database languages, but the one that we are going to use for a server is MariaDB, but the language that we're going to use is MySQL. So that is the database. So we are now how we have in these courses. In this course, we have tackled mentioned six languages that we learn we going to learn. First, we have HTML. Two is CSS. This is for the structured for our content for the front end, the layout, and the designing and doing the things which is very good for our eyes. JavaScript, GS is to make our front end much more interactive. Four, we have PHP for our scripting side language that really do the processing. And five, we have MySQL for our database concern. So in order for us to really create our application or mobile app web application, we must study five languages in one course. I know you can do it. You are really equipped on it. So next meeting we can really start with that. So okay. Now next we have it's almost now on end on my lesson. We are now on the web servers. So web server is computer where the web content is stored. Okay, so it's a web server. So like probably on your website is on it started online. So we can also set local servers soon. So basically web servers used to host the websites, but there exists on other web services also such as gaming, storage, file transfer, protocols, FTP, and email and etc. So web server hosts in a website. So it will be in order for our website to run, we should have at least we have a web server. So we have a web host that stores our codes, and we have a domain uh, that access our website. Okay, that www.fb.com, that is only a domain where we can access our website. But the host is another server where it is stored our program. Okay, so there are many web hosts so available in the internet. Web hosts like GoDaddy, Zero Web Hosts. There are many available. You can search in the internet web host and you can find it, and there will be a subscription every month where there will be a payment where the you can use their services in uploading your website by a subscription. It could be depending of the stories that you are applying. So the more stories that you are posting, the more expensive it is. So normally the web host servers, if you're going to host your website, it could be monthly for the subscription, and for the same for the web domain. Domain is only the URL where you can access your website, like www.webhost, for example, www.applicationdevelopment.com. That is a web domain where you can directly type your address. But basically, domain is an IP address that to pointing with your web host. But since you should your client on your website will doesn't really memorize the IP address for your your website. So that means you are going to apply web domain for a web host. So most of the time, if you subscribe, there you have a bundle. When you say the bundle, when you say you are subscribing host and also the domain with monthly subscription or yearly subscription. That is a work for web host, web servers. That it is where the web content is stored. So how web server works. So this is a diagram. So sending the file to the client associated with the requested URL. So with this web client, okay. Like for example, sa web client, we are sending requests like we're typing HTTP requests, like creating a post in the Facebook. So now we are now go to the web server. Then in our web server, there is a request for data, like posting that picture on the Facebook. So it will now go to static data store. It will post there. Then there will be a response from that. Then there will be an HTTP response for that. Um, Depending of the if you can view now the Facebook that the photo on Facebook you are posting, because in the web server also there is a servlet request where in the servlet request we have here application data store and the web container other services, because we have another um, processes. If you have we have we call it more uh, data store in your application, so you can have this kind of server request. So when client sends request for a web page, the web server reads on the requested. Then if the requested web page is not found, web server will send HTTP respond error for not found. So if client has requested for some other resources with the web server, will contact the application server and data store construct for HTTP response. Okay, most leading web servers. We have Apache HTTP server. It's the most popular web server in the world, developed by Apache Software. Light TTPD. It's a free web server that is distributed with a free BSD operating system. You have the Internet Information Service (IIS). It's a high-performance web server from Microsoft. Sun Java System Web Server is a web server from Sun Microsystem, is suited for medium and large websites. Zigzoo Server, Zigzoo 333 server comes from the World Wide Web Consortium. So these are most leading web servers, but since PHP is our language and Apache server is the server for PHP, this is where what we are going to look forward with our web server. Okay, so now how local host servers, how we can write our program locally since web servers are online. So once we develop it, we have to make sure that we can work it locally before uploading it in our uh, web servers online. So local host servers, a collection of tools that make hosting at local servers possible, so you can build or develop web apps at your own computer. So we are going to convert your local machine into a web developer software. Okay, so we have, since we are using the PHP language, this is the keyword, this is PHP server stocks. So these are the available PHP server stocks in the market. Okay, so we have WAMP, that's the abbreviation of Windows, Apache, Web Server, and MySQL. So Apache is the server for the PHP, and MySQL is the server for SQL, and since the PHP that is intended for only for PHP language. MAMP, we have Mac OS, still the same, Apache, web server, MySQL, and PHP. As you can see, the only is for the Windows. This map is only for Windows user. Map is this is for the ser, Mac OS user. So if you are a PHP server developer, if you are a PHP developer, you have to also determine what server stacks you are going to use. If you are using Windows operating system, probably you can use SWAMP. If you're using, you cannot use MAMP because this is for Mac OS. So LAMP, we have Linux, Apache, MySQL, and PHP. This is for intended for Linux operating software operating system. SAMP, this is a cross-platform Apache server, PHP, and Perl. So meaning, SAMP can be installed in Windows, can be installed in Linux, and can install with MAMP. So this is one is what we call SAMP. X means cross platform. Next is AMPS. Okay. Apache, MySQL, MongoDB, PHP, Perl, Python, and Solution, and Source. So this is for AMPS. Okay. So okay, another assignment. Okay, pause a video. Write your answer. Okay, this is question number 5. Why using service stack? Why we have to use service stack? Explain why we use service stack. Share your own idea. That is the last assignment for this video. Okay, so that's it. Okay, thank you. Thanks for listening. Does anyone have a question? Okay, if you have questions, you can send your email to me to my email grs@class.a.2122@gmail.com, or you can contact me on my number 0967-5749-778 for nurseedo.ph. Okay, thank you for listening. I hope you have learned something to me. Bye bye everyone. God bless us all.